We're kicking this off. This is day number 2 of JCON. We had a really good day yesterday. It was really great. We had a lot of participants coming back, telling us good feedback. We also like to hear, of course, bad feedback, so we can improve on that. All about Agile, right? And I want to start this off and do a little poll and ask some questions, because we're really interested in what you guys do. And the first thing I'd like to know is, who is already using any cloud environment in production? Show of hands. That's a lot of people. And who is using more than one cloud vendor? Who is using 2 or more cloud vendors? Okay, thank you. And who of you guys is using something that's described as function as a service, serverless, or something like that? Who is using that? Okay, so you all gotta learn something new today. And I'm really happy that David is with us from Oracle. He will give you some insights on how to use serverless, not only on Oracle, but on any platform. And yeah, David, I'm really happy that you're here and looking forward to hear your talk. Thank you.
Thank you. Okay, so first of all, thanks for having me today. It's really great to be here in Düsseldorf. So my name is David Delabassee. I work at Oracle in the Java platform group. So I have a question. Who in the room is using Java? Okay, so we are in the right room. So today I'm going to discuss Oracle Functions, Fn-Projekt, and Java. Before we do so, this is the standard safe harbor disclaimer slides from Oracle, so please read it with great attention. Thank you. This is my personal disclaimer. So I'm using a MacBook Pro, and if, like me, you are using a MacBook Pro, the latest design, you might know that there is a severe issue with the keyboard design. Apple has tried to solve that many times. It has been solved again in May during the last revision, but still it doesn't work. So it's the first keyboard in history to launch with a replacement program on day 1. Where I'm going with this? Well, today I'm going to do a few demos. If any of my demo fail, it's not my fault, it's because of the keyboard. And I'm serious about it. Okay, Oracle Function, Fn-Projekt, and Java. So before we talk about that, I want to step back and look at the evolution of compute virtualization. So basically, over time, there has been a trend to basically increase the abstraction of the platform. So we went from bare metal to virtual machine to container. Serverless, function as a services, is just an evolution of that trend. So by increasing the abstraction, basically we also decrease all the concerns that are related to the underlying platform. We don't get to see the underlying platform. We don't get to manage the underlying platform. It's basically someone else's responsibility to make sure that the platform is provisioned and run. So that provides a lot of benefits in the sense that we can finally really focus on our business code. So if you look at the left side, when we had bare metal deployment, basically we had to manage everything. So from the code to the hardware stack. So then came the virtual machine that give us more abstraction, then containers give us more abstraction, and finally we have this nice function as a services approach, which gives us the ability to just focus on the code. So from left we have a stateful, full-blown application. Going to the right, we are evolving towards not even applications, we are evolving towards functions. So basically, well-bounded piece of code that will perform just one task. Those functions on the right side will be most of the time stateless. They will be ephemeral. So on the right side, we have full-blown application that will be deployed and run for weeks, months, years. On the right side, we have piece of code that will basically be invoked on demand. They will perform one task and then they will die. So we have this notion of stateless, ephemeral code. On the right side, the cost was fixed. So basically we had to pay for everything regardless of the infrastructure, if the infrastructure was used or not. On the right side, we are evolving towards a model. It's basically a pay-as-you-go pricing model. So you are paying whenever your code is running. If your code doesn't run, well, you don't have to pay anything. And clearly, the right side provides many benefits. As you see, we just have to focus on writing business code. We don't have to focus on how can we scale that code, on how the platform should be managed, and so on and so on. So serverless is basically an abstraction of all the underlying abstraction. Serverless in itself is a very broad term, so it covers quite many things. So today I'm just going to focus on one aspect of serverless, which is function as a services. So basically how we can take some code and give it to a platform, and then it's up to that platform to make sure that everything runs. So basically FaaS, function as a services, is the compute element on which your code will run on. So you give the code to the platform, and it's up then to the platform provider to make sure that everything works. The programming model is pretty straightforward. So we have the notion of a function. So within the serverless space, within the FaaS space, we don't have application, we have function. So a function is basically a well-bounded piece of code that will just perform one task. The function will get something in input that will trigger the function execution, and most of the time the function will provide some kind of output in a queue, in a database, to an HTTP endpoint. It doesn't really matter. And obviously, we have a bunch of functions. So the idea is that over time, you might want to compose together those functions to provide higher level functionality. But clearly, those are not full-blown applications like we had in the past. In terms of use case, if you have anything that is highly event-driven, FaaS makes a lot of sense. So there's some data coming in, you want to react on that data, then it makes sense to write some function to do that. So think about batch job, for example. So a bunch of data that need to be processed at a certain time, those kind of things. So again, FaaS, function as a service, is not a silver bullet. So you will not necessarily write full-blown application using a serverless platform. But still, there are a lot of use cases where it makes sense, or when function can be used next to an existing monolith applications. So Oracle Function is basically Oracle's offering when it comes to function as a service. So it's a full-blown managed FaaS platform. It's a pay-per-use model. So your function are invoked, you will have to pay a little bit. If your function doesn't run, you don't have to pay. That's the basic idea. It's autonomous in the sense that everything is managed for you. So you don't have to worry about which version of the operating system should we use, which version of the Java runtime should we use. How can we scale the function? How can we secure the function? And so on and so on. That's something that we handle for you. And something which is quite key at the bottom is that we try to avoid any lock-in to Oracle. So under the hood, Oracle Function is using Fn, which is an open-source project. So it's basically an open-source FaaS platform that we will see later on. And that gives you the ability to use our offerings, Oracle Function in Oracle Cloud, but you can also take Fn and run it on premises or on a different cloud provider, given that everything is open source. Now, something that we have to keep in mind is that the value of a FaaS platform is obviously the FaaS platform itself, but the value is also coming from the adjacent integration it has with different services from the cloud provider. In the case of Oracle Cloud, we obviously have a deep integration with all the OCI services, such as, for example, the registry. So you will see that in Fn, Enhanced Oracle Function, everything is a container. So that means that we need a registry. And obviously, on the Oracle side, we are making sure that, for example, at the network level, everything is optimized. So the registry and the Oracle Function instance server are co-located so that we can get the best in terms of performance. So just keep in mind that integration with other services is also something which is quite important when it comes to a FaaS platform. Now, this is not a product pitch, so I'm not going to discuss in great details the pricing, but you can get up to 2 million requests for free per month. So that gives you the ability to test the platform, to play with the platform and do small-scale deployment. And then obviously you will have to pay. But you see that in terms of pricing, it's quite competitive. So that's something that you need to look at. Again, this is not a service pitch. So I'm going to focus now on Fn. Fn is basically the FaaS platform that Oracle is using for Oracle Functions. So it's an open source FaaS platform. Oracle is obviously heavily contributing on that project. Everything is on GitHub. So one of the benefits of that is that As already mentioned, you take Fn, you can run it on your laptop. That's what I'm doing here for my demos. But you can also take Fn and run it on any type of cloud provider. Obviously, if you are doing that, that means that you will have to manage a platform. So you will have to deal with the two hats. You will be on one hand the function developers, and on the other hand, you will also be the FaaS-Plattform providers. So you will have to then worry about how can we scale the platform and so on and so on. Basically, we're providing you choice. So it's open source, it's Apache v2 license, everything is on GitHub, it runs anywhere. Technically, Fn is written in Go. It makes sense. Fn leverage Docker, which is written in Go. It's an infrastructure project, such as Docker or Kubernetes. So it makes sense to write such project using Go. Having said that, Fn is polyglot. So you can write function using Go, so you can have a Go function, but you can also have Python function or Node function, and so on and so on. And given that we are Oracle, obviously, we spend a lot of time to make sure that Java runs great on with Fn, and that's what I'm going to discuss later on. So in Fn, everything is a container. So a function is basically simply a container. So you as a developer write a piece of code that will be then turned by the platform into a container. So you don't have to worry about how should I write or how should I turn my code, Java code, Go code, Python code into a container, into an optimized container. That's something that the tooling, so the Fn tooling does for you. That's obviously the same tooling that we are using for Oracle function. So everything is a container. So that basically means that we are leveraging well-established now technologies. Now, the next question, I'm going to first do a quick Fn demo so that you can see how it works. So I have here Fn running on my machine. So I told you that everything in Fn is a container. It's already running on my machine. I'm going to stop it so that you can see how fast is it. So Docker PS, there's nothing running. Fn start I said -d. Fn is now started on my machine, Docker PS again, and it runs within Docker itself. So the next thing that we want to do, we want to create a function. So we need to specify a runtime. We could say Go, we could say Node, but obviously given the context, we're going to use Java. And then we need to give our function a name. Let's call it jfunc. And we have a function that has been bootstrapped. So if we look there, we have a bunch of files, including a pom.xml. So basically a Java function in Fn and Oracle function is simply a Maven project. So you can keep using IntelliJ or any type of IDE. We then have two classes, a hello function, so it's basically a simple hello world that you can extend, and a hello function test, which is a JUnit test for that function. So if we look at the function itself, main, oops, sorry. You see, that's a hello world function. So there's no interface, there's no annotation, it's basically plain old Java code. So we have one class in this case with one method that will get, in this case, a string input, and it will produce some output. So it's pretty basic. So the next thing that we want to do, so we have the function bootstrap, we want to deploy it. So for that, we need to create an application. An application is simply a way of grouping together related functions. So let's create the JCON function, and then we can deploy function within that application. I'm going to use the verbose flag so that we can see what's happened behind the scene, and I'm going to use the local flag to save some time. And well, you see that behind the scenes, the Fn tooling is using Docker to basically here, let's see. So basically compile the function. So the function is being turned into a jar. And then we copy this jar into a specific image, a Java FDK, so a Java Function Development Kit image that has been optimized to run functions. So that's one of the things that Fn is providing, those optimized images to make sure that your function run in a secure and fast way. So our function is deployed. We can now invoke the function. So the application is JCON, and the function is jfunc. We can pass it some payload, -n JCON, so it's pretty basic. Hello JCON. We can inspect the function. If I inspect function, JCON, and the function is JCON. And we see that by default, our function has an HTTP endpoint that we can use to invoke it. We can define additional triggers, HTTP triggers, HTTPS triggers, or even triggers to invoke our function in different way. So that's basically FN, a very quick overview of FN, how it works. So the next question is, the next point I want to discuss is Java. Given the context, I thought that it would be useful to discuss Java. So the idea is that I basically want to show you what we're doing, in terms of investment on the Java platform that makes sense for Oracle function, FN, and for you people that are using Java containers and serverless platform. So today, well, last week, sorry, we have released Java 13. No big surprise. I mean, with the new release cadence, every 6 months we have a new Java release. So Java 13 was released last week, and Java 14 will be released in March 2020. The current long-term release support being Java 11. I'm not going to discuss this in details because I know that Wolfgang has a session this afternoon that will cover that. But just be aware, Java 13 is the current release, and Java 11 is the long-term support release. So if we look at the content of Java 13, we have five new JEPs. 2 of those are still in preview. So one might say, okay, this is not a large release. On one hand, it's true, because we only have 5 large features, and 2 of them are not even final. But on the other hand, JEPs are not the only thing that we're doing within a Java release. So if you look at the release notes, you will see that there are a bunch of other features which have been added in Java 13 that are not defined through JEPs. And still, those features are important for Java developers. Not only that, each release comes with a set of issues fixed. In Java 13, we have fixed over 2,000 issues in that release only, so that's quite a lot. So in terms of scope, Java 13 is still an important release. So I'm going to discuss just one feature out of those 5 JEPs, and that's CDS, because it makes a lot of sense within the FaaS space. So what about Java within the serverless space? At the end of the day, it all boils down to running Java into containers. So if you look at Java function running in FN or running in Oracle function, it's basically just making sure that those Java code runs well within containers. So if you look at the market more broadly, you can see that all the FaaS platforms are using containers. On one hand, we have the FaaS platform such as FN, Oracle function, OpenFaaS, and so on, that are explicitly using containers. So we're not hiding the fact that containers are used under the hood. And on the other hand, you have platforms such as AWS, for example, that are also using containers, but in a more implicit way. So it's not necessarily exposed that containers are being used, but still, they're using containers. So at the end of the day, regardless of the platform that you're using, it all boils down to making sure that Java runs well into containers. So there are 2 things that we need to focus on. The first one, we need to make sure that the Java virtual machine behaves correctly whenever it runs within a containers. That's something that we will see later on why. And then we also need to work on the latency. So if you look historically, Java has been optimized for long-running applications. So we deploy an application in an application server. The deployment might take some time, 10 seconds, 1 minute. It doesn't really matter because that application will basically run for months. Here we are talking about Java code that will be invoked on demand, like that. So I'm invoking in function, so some payload will trigger a function execution, the function will perform its job, and after 1 second, 2 seconds at most, the function will die. Obviously, the startup time in that scenario is important. We don't want the JVM to take like 5 seconds just to start a function that will only live for 500 milliseconds, for example. It wouldn't make sense. So latency is key. And when we look at latency, so basically the time it takes to start up our function, we can distinguish 2 levels. The first one is the container level. So we need to make sure that the container starts as quickly as it can. And the other level being at the Java layer. At the Java level itself, we want to make sure that the Java code starts also very fast. So if we look at the containers is simply a bunch of layers stacked together. For a Java function containers, it's basically, we can distinguish 3 types of layers. We have the operating system layers, we have the Java runtime layers, and we have the Java application, so the Java function layer will hold all its dependency. And what we want to do, we want to make sure that those layers are as small as possible. Why? Because each time you want to invoke a function, the container will have to be loaded from a registry. So if one of that layer weighs 500 megabytes, each time the function will be invoked, you will have to load from the registry, well, the platform will have to load from the registry that 500 megabyte layers, which is very expensive, obviously. So layer size is something which is very important. So top to bottom, if we look at the first layer, so the Java function layers, there's not much that we can do as a platform. The only thing that we can do is basically give you advice and best practices. Typically, if you have a Java function, watch out for the dependency that you're using. Watch out for the transitive dependency. Don't bring any dependency that are not needed. Those kind of things. If you have anything that is highly static, well, it might be a good idea to put that in a different layer so that we can leverage the cache mechanism of the container technology that we are using. Those kind of things. Now, if we look at the Java runtime layer, there are things that we can do to basically reduce the size of the layers. So you know that in Java 9, we have introduced modularity in the platform. And with that, we have a tool that is called JLink that gives us the ability to construct a custom GRE that only carry the modules that our code needs. So to give you some idea of the benefit that we can get using JLink, I took first a JDK 12. I didn't have the time to update my slide for 13, sorry for that. But nevertheless, the figures should be more or less the same. So a whole JDK 12 weight, let's say 320 megabytes. That's a lot. So it's not a good idea to use a JDK to run Java code, because the JDK carry a lot of tools that are not needed to run your code, like Delabassee, for example. So whenever you run code, you should use a GRE. Now, there's no Java 12 GRE, so I pick a distribution, so OpenJDK 11 GRE Slim, which has a GRE, and I only picked the GRE out of that distro to have some idea of the size of a GRE those days. 220 megabytes. So just by switching from a JDK to a GRE, not only it's a good practice from a security standpoint, because you don't carry things that are not needed, but you already save 100 megabytes. Now, JLink gives us the ability to create a modular GRE that only contains the modules that we need. So what I did next is basically create a custom GRE with all the modules. That's stupid, because there is no way you can write an application that would use, a meaningful application that would use all the modules from the GRE. But again, this is just to give us some idea. So that GRE weighs 170 megabytes, so that's already better. We can, using JLink, remove some unneeded information at runtime, like header files, man page, and so on. If we do that, we save another 25 megabytes. And then we can also compress our GRE. We have two levels of compression. Level 2 is zip deflate, and we go down to 84 megabytes. So we save already quite a lot. But obviously the main idea of JLink is to have a Java runtime that only carry the modules that our code needs. So I did that for a function, and a custom GRE runs on the base modules. I'm also using logging modules, it makes sense. And if by doing that, we go down to 48 megabytes. So that's all the GRE that is needed to run a Java function within Fn and Oracle function. Obviously, we can still remove some information that are not needed in our runtime, 41 megabytes, and we can compress that to level 2, 32 megabytes. So in 32 megabytes, we have a Java runtime with everything needed to run our Java function. So basically, we went from 320 megabytes, a full-blown JDK, to 32 megabytes. So you see that JLink provides a lot of benefit when it comes to reducing the size of the layers. Now, the idea of JLink is basically to remove useless information, so to reduce the size of the layers. Something that you have to keep in mind is that if we are using compression, that will come at a cost, because we have to decompress the compressed stuff. And my experience shows that compression might not be a good idea. So you'd rather stick with removing all the header files, stripping out the debug information, and then don't compress your GRE. because those days we have very good networks, so it might be better to rely on the network capability instead of paying the cost of decompression. So the next thing that we can do to reduce the layer size of our Java function, of our virtual machine running in a container, is to use an highly optimized Linux distribution, such as Alpine. So Alpine is a security-oriented lightweight distribution that weighs between 4 and 5 megabytes. The issue is that Alpine relies on muscles. So muscle is an alternative to libc, libc being the C library that the JVM used to talk to the Linux operating system. So we have Project Portola, whose goal is basically to compile OpenJDK on top of muscles. So with Portola, we can use OpenJDK on top of distributions such as Alpine. So let's have a quick look at that. So I'm going to create a function in it, image. I'm going to use JDK 14 because 13 is so last week, and I'm going to call it Java 14. So it's again a simple hello world function. I'm going to deploy that function. Java 14, and I'm going to so this is our function, so it's again a hello world function. No, sorry, JCON, Java 14, hello world. Now, what's interesting is that if we look at the container image that has been generated, so Java 14, oh, sorry. Oops. This is the image of our Java function that includes everything. So the first layer, 4.1, is the operating system. So we have a full-blown Linux to run our function. We then have these 2.4 layers, which is our Java function. Well, with the resolution we don't necessarily see, but we have the function.jar and all the dependencies that are needed by the Java function. And then we have this 33 megabyte, which is the custom GRE. The custom GRE that we have produced with everything and just that needed to run the function. And finally, we have this 20 kilobyte object, which is just something that is needed by the platform. So you see that basically by using Project Portola with JLink or just JLink, you can greatly reduce the size of your layers. And that's something which is key when it comes to quickly start up those Java functions. So we know what to do at the container level. We want to reduce the size of the layers as much as we can, but we also have to now to worry about the Java layers. So how can we make sure that our Java code starts as quickly as possible? So this is a startup time of a simple hello world from Java 8 to Java 9. And clearly, smaller is better. So, well, you can clearly see that in Java 9 we had a big regression in startup time for different reasons, but nevertheless it wasn't very good. So I'm going to share with you a secret that we're using internally at Oracle to basically reduce the startup time of our Java application, and this gives us that. So on the right side you have the startup time of the same code but on Java 13. And that secret is basically just switch to a newer JDK. So obviously we have fixed that bootstrap regression that we had in JDK 9, but not only that, with each release of Java, we are making sure we are spending time and energy to try to reduce the startup time. And you see that now basically Java 13 is below the startup time of Java 8. Obviously that's one benefit, but that comes with a bunch of additional benefits because we have Java 13. That basically means that we have access to all the new capabilities that have been added to the platform, including modularities, HTTP2, TLS 1.3, and so on, basically all the capabilities that are added over time. So that's something that you should do whenever you can. Not only that, it's not on my slide, but in the early days of Java 8, we also had issue with the Lambda startup time. The first time you start up a Lambda, it was very expensive, because the JVM had to do a few things this has been optimized. Now the Lambda startup time is very good. So something else that we are heavily using to improve the startup time is CDS, class data sharing. So the idea with CDS is whenever the JVM starts some Java code, whenever the JVM starts a Java application, it basically needs to load the class from the disk and turn that into a memory representation. And that is a very expensive operation because for each class, it loads the bytecode from the disk, it turns that into an in-memory representation, but before that it has to do security checks and so on and so on. And the issue is that obviously you have a bunch of classes, you just not have one single class. The main idea of CDS is basically we do that work once. So, and once we have that in-memory representation, the JVM will dump that into the disk. So the next time that Java code, that Java application is started, there will be a mapping directly from disk to memory, so that the JVM doesn't have to go through all the steps of basically converting and loading that into memory. It's not something new, something that we have in the platform since quite some times, but let's have a look at how it works. So let's see, CDS, so let's see, JCON. I'm going to use a different. So I'm going to connect to an OCI instance that runs Ubuntu, because I need Linux to show that. Java 13, okay. Oops. So I have a simple hello world that I'm going to compile. Yeah, oh yeah. Just in case in those days you can do that. Sorry, Java dot. So you directly invoke Java on a class and it will compile, but that's not what I want to do. So I really want to compile the class. Sorry, JavaC. That's the keyboard, it's not my fault. So let's invoke this simple application, and it's pretty basic. It just displays some runtime environmental information. So what I'm going to do, I'm going to invoke that application many times, 42 times to be more precise. And I'm going to disable CDS because on Java 13, on 12, it's on by default. So my simple application is being invoked 42 times, and it takes 193 milliseconds on average. So now I'm going to do the same, but I'm going to use, well, I'm just going to remove that because it's on by default. And you can already see that it's faster. So from 193, we went to 134. So that basically means that we are around 70% of the startup time with CDS than without CDS. That's something that you have for free in the platform. So that's something that you should leverage. So CDS is not something new. It was part of the platform since Java 5. In the early days, it was fairly limited. It was just for the runtime classes and just for with support of serial garbage collect. In Java 9, we have added support for application CDS. It was a commercial feature. So the idea is that at the beginning, in the early days, you could only use CDS on the runtime classes. Since Java 9, you can use that with your own classes. That feature has been open source in Java 10, so that's something that is part now of OpenJDK. And we're improving CDS. For example, in Java 13, we have dynamic CDS. So the idea is that you want to generate the dump of the classes of your application. That's a manual operation. So you first need to create the list of class that you want to dump. Then you create the archive. And then you use the dump, when you launch your application. In Java 13, it's something that will be done automatically when the application exits. So you don't have to go through all those manual steps. So that's the kind of improvement that we're doing in the platform. So again, use CDS. Now, CDS with application CDS with serverless function, it depends. Sometimes it doesn't really provide benefits. If the application is very small, if the function is very small, application CDS might not be needed. So something that you have to keep in mind is that with CDS, we are also increasing the size of the layers. But again, the startup gain that we get by using CDS is worth the cost of increasing a little bit the layers with those archives, those CDS archives. Don't take my words for it. So this is a tweet from last week from Charles Nutters, and basically it just prays about the startup time that JRuby, which runs on Java, has now using CDS. Those are the numbers he published. So if you look at the bottom, Java 8, the startup time of JRuby was 853 milliseconds. With CDS, application CDS, 717 milliseconds. So that's something that is free, that you should use. It doesn't cost anything, and it brings real benefits. Something else that we can use to improve the startup time is GraalVM. So the idea with GraalVM, it provides many features, but one feature, native image, is basically, it gives us the ability to take some Java code and ahead of time compile that Java code into a native executable. So at the end of the day, what we will have using native image would be a Linux executable that will carry its own, that will embed its own virtual machine, the substrate VM. So I don't have the time to show you how it works with Fn, but I believe I have an image here. Yes, FNLS. So if we look at this Graal application, it has one function. It's a native function. So it's a Java function that has been compiled into a native executable using the native image. And if we look at the size of that function, so we have so the first layer, 4.4, is the operating system layer. Sorry. And 16 megabytes is basically the function itself. So if we look at that, we have this executable. It's just a binary that includes the function and substrate VM. So everything needed to basically run the function. So there's no external GVM needed. And we still have this 20 kilobyte shared object that is needed by the Fn and Oracle function. Not only that, by using GraalVM, you will also reduce the footprint of your function. So that's something that you can use. Having said that, there's no free lunch. Graal has some limitations that are being worked on. Like today, it only supports Java 8. It will shortly support Java 11, but that's not something that is trivial. And there are a few limitations when it comes to the code. Basically, everything which is dynamic, proxy, invoke dynamics will not run on native image. But if you can work around those limitations, it makes sense to have a look at Graal and the native image capability. So last, container. The GVM should run and behave as a good citizen when it runs within containers. So I'm not going to spend time on this, but the takeaway here is that with each release, we are making sure to improve how Java and the Java machine runs into containers. And one reason for that is what we call the ergonomics of the platform. So the ergonomics of the platform is something that was started a long time ago, and basically it gives the ability to the Java virtual machine to auto-tune itself. So the virtual machine will look at how many CPU it has, how many memory it has, and it will try to provide a default behavior that would make sense, that would provide a decent performance. So I have here, let's see. Oops. So I have a simple Docker file. And let's take that same hello world. Let's build that Docker image. And we'll see why it's important. So let's run that, Docker run, and the image is JCON. To Java. Oh, and I can know what's going on. Yes. Made Docker file. Copy. Run Java C. Hello world. Java, and then here it's Java hello world. So that should. close first. Run, run. So this is basically what my JVM see inside when it runs within that container. So it sees 3 cores, which is what I have on my machine. It's a 4-1, and the command for join pool is configured according to those 3 cores. Now what I'm going to do, and I need to look because I always forget, yes. So I'm going to limit the resources that are allocated to my container to 1 CPU. And you see that basically, so my container has only 1 CPU, and you see that my Java virtual machine still see 3 cores. So basically it configures my foreground pool on 2 cores, and I only have 1 core. So I'm pretty sure that I will shortly have issue if I have a long run, well, if I'm trying to run an application within that context. Not only that, the memory is also configured using that information. So if I limit my memory to, it's minus, let's say, 64 megabytes, my container still, my Java virtual machine in my container still has no clue about exactly what environment it's running, and it will provide a behavior that will clearly not match the resources that we have. So to fix that, pretty easy. No, build first. So I'm switching to the latest release of OpenJDK, and now if I run within 1 CPU, you see that I only have 1 core, so my foreground pool is configured to 1 core, and so on and so on. So everything, all the ergonomics are based basically on the CPU that are available, the number of CPU and the memory that is available. So for example, GC is also decided based on that information. In the first scenario, I was using an old Java 8 version, which is not container aware, so I was clearly misleading my JVM, and well, that would lead to very quickly to very bad behavior. So that's why it's important to use recent version of the JVM. So Oracle function, Fn-Projekt, and Java. It's time to wrap up. So as I said, it all boils down to Java virtual machine running in containers, regardless of the fact that you're using a FaaS-Plattform or not, or Oracle function, Fn, or any type of FaaS-Plattform. It's basically just Java in containers. So we have seen different techniques and approaches that we can use to improve the latency at the container level, but also at the application Java level. I've quickly shown why it's important, why all the investment that we're doing in the JVM are important. We want to make sure that the JVM behaves correctly whenever it runs within the containers. That's something which is obviously very important. Some advice, use a GRE instead of a JDK. That's a common sense. To run application, you don't need Javac, so don't carry Javac. Use the latest version if you can. If you can't, you need to make sure to rely on an actively supported version. Not only you will get all the benefits, but also from a security standpoint, it's also a better approach. Try to move the startup cost to build phase. That's what we're doing with CDS. So we're basically doing that at build phase so that when we run the application, we save time, and then the rest is basically just container as usual. So smaller image are better, and so on and so on. Another advice, choose your base image wisely. You might have seen this tweet. The top 10 most popular Docker containers contain at least 30 vulnerabilities. Java is not there, but it's not, that doesn't mean that we are on the Java side necessarily immune. So choose your base image wisely and secure it. That's something which is obvious, but very important, believe me. One more? Yeah. That was very secure. Or you might want to give a try to Oracle function. If you have those scenarios where you have highly event-driven needs and you are using Java, a FaaS-Plattform such as Oracle function makes lots of sense. It has a free tier, so it doesn't cost you anything to give it a try. As I said, 2 million requests per month, and it's only then that you need to pay a little bit, like 20 cents per additional million requests, so it's very cheap at the end of the day. If you are moving towards that services, It will save you all the hurdle of securing, well, finding the right image to use, tweaking the JVM, using the right JVM, securing the platform, and so on and so on. So that's something that you should really consider. It also makes a lot of sense. We also have a free tier for Oracle Cloud. Function is not in there. It's not in the always free. So it's basically just compute and database. It's always free. But that means that you can also take Fn and run it for free on top of Oracle Cloud. And it's always free. Now, just use the free tier of function. It's also free. So we are very good at Oracle to have different type of free. So we have always free. We have 30 days free. And we have the free tier of functions. So just pick the right one. If you are interested in FaaS, I would encourage you to check the function free tier. And with that, I'd like to thank you for your time. Thanks.